Hey everyone, welcome back for another deep dive.
I'm glad to be back.
Today, we're going to be looking at two concepts that are like super fundamental to programming.
Yeah, definitely fundamental.
Functions and recursion.
Yeah.
Um, and luckily, we've got some really good material to work with that explains not only like what they are, but why they're so useful.
Mm-hmm.
So our mission today, I guess you could say, is to make sure that like by the end of this, we both have like a rock solid understanding of functions, what they are, how to use them.
Yes.
Same thing for recursion, and then like why they're so useful for writing good code.
Absolutely.
So I guess to kick things off, have you ever, like when you're writing code, have you ever found yourself like writing the same bit of code like over and over and over again?
Oh, absolutely. I mean, especially when you're first starting out, you kind of, you don't really know the tricks of the trade yet, so you end up just repeating yourself, and it gets pretty messy.
Yeah. Yeah, it's like, you're trying to get something to work and you're just like copy, paste, copy, paste,
Yeah.
copy, paste.
Exactly. Yeah.
Or like maybe not even copy and paste. Maybe you're just like rewriting it from scratch each time because you don't realize that you're doing the same thing.
Yeah.
Or have you ever been like working on a problem that just like, it just feels so complex. It's like, how am I ever going to break this down into something manageable?
Yeah.
So if you've ever run into those situations, then functions and recursion could be like really useful tools for you.
Absolutely. And the cool thing is they kind of like they dovetail into one another. Functions are great for organizing your code. And then you can use recursion sometimes within a function to really elegantly solve some problems.
Yeah.
Yeah.
So, okay, let's just jump right in. Let's start with functions.
Okay. Sounds good.
So I think the simplest way to think about a function, at least in Python, is it's like a reusable block of code. It's a set of instructions that performs a very specific task.
Yeah.
So instead of like, writing the same lines of code over and over again every time you need to do that thing, you define it once in a function.
Right.
And then from that point on, anytime you need to do that thing, you just call that function.
There's having a little helper, right?
Yeah, it's like a little helper, exactly.
Yeah.
And the cool thing about that is, it obviously it makes your code shorter because you're not repeating yourself.
Right.
But it also makes it like way easier to read.
Oh, absolutely. Yeah. I mean, think about it like a book, right?
Yeah.
If you had a book and every time a character like walked into a room, you had to describe their entire outfit again from scratch, like it would get really tedious to read, right?
Yeah.
But instead, you could just be like, oh, Bob walked into the room, and you already know what Bob looks like because you described him earlier.
Right.
It's kind of the same thing with functions. You define it once, and then you can just refer to it by name, and it makes your code a lot more concise and readable.
Yeah. And, even beyond just like making it easier to read, it makes it way easier to debug. Because like, let's say you have this thing that you're doing over and over and over again in your code.
Yeah.
And then you realize like, oh, shoot, there's a bug in this.
Yeah.
If you've written it out every single time, you're going to have to go and fix it every single time.
Right. You got to hunt it down every time. Yeah.
But if it's in a function, you just have to fix it once.
Yeah.
And then it's fixed everywhere.
Yeah. You fix it at the source.
Exactly.
And it propagates out to the rest of your program. Yeah.
So, it's more than just avoiding repetition. Functions also help you to like break down a program into more manageable chunks.
Yeah.
So, if you've got this like really complex program, it can be really overwhelming to look at it and be like, where do I even begin?
Right.
But if you could break it down into these smaller chunks, where each function is responsible for like one specific task.
Right. A discrete task.
Yeah, then it just becomes so much easier to like wrap your head around.
It's almost like outlining a paper, right?
Yeah.
You break it down into sections. You have
Right.
your intro, your body paragraphs, your conclusion.
Yeah.
And each one has a specific purpose, and then you can kind of focus on one at a time.
Exactly. And like if something goes wrong, it's so much easier to like narrow down where the problem is.
Yeah. Yeah. I mean, debugging is like probably most programmers' least favorite thing to do.
For sure.
So anything you can do to make that easier, definitely worth it.
Yeah. So, okay, that's like kind of the high level overview,
Yeah.
like what functions are, why they're useful.
Right.
Let's talk a little bit about the actual syntax. Like how do you actually write a function in Python?
Okay.
So the basic syntax, it starts with the keyword def, which is short for define.
Okay.
So you're basically telling Python, hey, I'm about to define a function.
Right.
And then you give the function a name.
Right. Give it a descriptive name so you know what it does.
Yeah, something that makes sense.
Yeah.
And then you have parentheses. And inside the parentheses, you can put what are called parameters. And we'll get into those in a little bit. But basically, parameters are they're like variables that you can pass into the function.
Right. So you can customize what the function does. So.
Exactly. And then you have a colon. and then you have an indented block of code. And that block of code, those are the instructions that are going to be executed when you call the function.
Right. So that's the actual like meat of the function where the work gets done.
Exactly. And then finally, you can have a return statement. And the return statement is optional. But if you have it, what it does is it sends a value back out of the function.
Right. So if you want the function to like calculate something and give you the answer, you would use a return statement.
Yeah.
Yeah.
So, okay, let's look at a super simple example. Let's say we want to write a function that just prints a greeting.
Okay.
So we would start with def, and then we would give it a name. Let's call it greet. And then parentheses. And for now, we're not going to have any parameters. So the parentheses are just going to be empty. And then a colon. And then on the next line, indented, we would have print, and then in parentheses, in quotes, hello, welcome to Python.
So if you were to run this code, it wouldn't actually print anything yet, right?
Right.
You've just defined the function. You haven't actually told it to run.
Exactly. This is just the definition. We're just saying, hey, Python, here's what this function is. Here's what it does.
Right.
But to actually make it run, we have to call it.
Right.
And to call a function, you just write the name of the function followed by parentheses. So in this case, we would just write greet, open parentheses, close parentheses.
And then that would actually execute the code inside the function and print the greeting.
Exactly. So that's like a really basic example, right? It doesn't take any input. It doesn't return any value. It just does one thing.
Right. But it illustrates the basic structure. You've got the def keyword, the name, the parentheses for parameters, the colon, the indented block of code, and in this case, just a simple print statement.
Yeah. So now let's make it a little bit more interesting.
Yeah.
Let's say we want to write a function that adds two numbers.
Okay.
So we would start the same way. Def. We'll call it add.
Okay.
And then this time in the parentheses, we're going to put two parameters. And we can call them whatever we want, but let's just call them A and B.
Okay.
So it'll look like def, add, open parenthesis, a comma B, close parenthesis, colon.
Right.
And then on the next line, indented,
Mm-hmm.
we would do something with those parameters.
Yeah.
So we can say result equals A plus B. So we're taking the two values that are passed in as parameters, we're adding them together, and we're storing the result in a variable called result.
Right.
And then we could print that result.
Okay.
So we can say print, open parenthesis, in quotes, sum, close quote, comma, result, close parenthesis.
Gotcha. So when you call this function, you would pass in two numbers, and it would add them together and print the sum.
Exactly. So if we called it like this, add, open parenthesis, 5 comma 3, close parenthesis, it would print sum, 8.
Makes sense. So the 5 and the 3, those are the arguments, right?
Yes, exactly.
Actual values that you're passing in when you call the function.
Exactly. And the A and the B, those are the parameters.
Right. The placeholders in the function definition.
Exactly.
Okay.
So now let's do one more example. Let's say we want to write a function that multiplies two numbers, and then it returns the result.
Okay.
So it's going to be very similar to the add function.
Right.
We'll start with def. We'll call it multiply.
Okay.
Open parenthesis, x comma y, close parenthesis, colon.
So X and Y are our parameters this time.
Exactly.
Gotcha.
And then on the next line, indented, we would say return x times y.
Okay, so instead of printing the result directly, we're using the return statement to send it back.
Exactly. So when we call this function, it's going to calculate x times y, and then it's going to give us back that value.
Right.
And we can do whatever we want with that value. We can store it in a variable. We can use it in another calculation. We can print it.
So how would you actually use this multiply function?
So let's say we want to multiply 4 and 5.
Okay.
We could say product equals multiply, open parenthesis, 4 comma 5, close parenthesis.
Okay.
So we're calling the multiply function. We're passing in 4 and 5 as the arguments.
Right.
The function's going to calculate 4 times 5, which is 20, and then it's going to return that value.
Mm.
And we're storing that value in a variable called product.
Gotcha.
And then we could say print, open parenthesis, in quotes, product,
Mm.
close quote, comma, product,
Yeah.
close parenthesis.
Okay.
And that would print product 20.
Gotcha. So the return statement basically lets the function produce a value that we can use elsewhere in our code.
Exactly.
Yeah, it's really powerful.
So that's kind of like a quick overview of functions. We define them using def. We give them a name. They can take parameters as input. They execute a block of code, and then they can optionally return a value using the return statement.
Right.
And the big advantages, like we said, are that they allow us to reuse code, which makes our programs shorter and easier to maintain. They make our code easier to read and debug.
Absolutely.
And they help us break down complex programs into smaller, more manageable pieces.
Yeah.
So are you ready to move on to recursion?
I am, yeah. It's a little bit more mind-bending, but it's really cool once you get the hang of it.
Yeah.
Yeah.
So recursion, you can think of it as like a function calling itself. But it's a little bit more nuanced than that.
Yeah.
So the idea with recursion is that you're breaking down a problem into smaller, self-similar subproblems.
Right.
And then you're using the function to solve each of those subproblems.
Yeah, and it's important to note that each time the function calls itself, it's working on a slightly simpler version of the problem.
Exactly. And it keeps doing that until it reaches a point where the problem is so simple that it can be solved directly without having to call itself again.
Right, and that point, that stopping point, that's called the base case.
Yes. The base case is super important.
Yeah, it's crucial. Without a base case, your recursion would just keep going forever, and you'd get what's called an infinite loop.
Right. And then your program would crash.
Exactly.
So, okay, let's look at an example to make this a little bit more concrete.
Okay.
So a classic example of recursion is calculating the factorial of a number.
Right.
And just as a quick reminder, the factorial of a number it's the product of all the positive integers less than or equal to that number.
Yeah.
So, for example, 5 factorial, which is written as 5 with an exclamation point.
Right.
It's 5, 4, 3, 2, 1.
Which is 120.
Which is 120, exactly. So we can actually calculate a factorial using recursion.
Okay, how would we do that?
So we would define a function, let's call it factorial, and it's going to take one parameter, which is the number that we want to calculate the factorial of.
Okay.
So it's going to look like def factorial, open parenthesis, n, close parenthesis, colon.
Right.
And then inside the function, the first thing we're going to do is check for the base case.
Right, so that's the condition that will stop the recursion.
Exactly. So the base case for factorial is that if n is 0 or n is 1,
Yeah.
then the factorial is 1.
Right, because 0 factorial and 1 factorial both equal 1.
Exactly.
Yeah.
So we would say if n is equal to 0 or n is equal to 1, then return 1.
Okay, so that handles the simplest cases.
Exactly. And then if n is not 0 or 1,
Yeah.
then we need to do the recursive step.
Right, so this is where the function calls itself.
Exactly. So we would say else. Return n times factorial of n minus 1.
Okay, so it's multiplying n by the factorial of n minus 1.
Exactly.
And that's the recursive call.
Exactly. So it's calling itself again, but with a smaller value of n.
Right.
So let's say we call factorial of 5. So the first thing it's going to do is it's going to check, is 5 equal to 0 or is 5 equal to 1?
Yeah.
And the answer is no.
Right.
So it's going to go to the else block.
Yeah.
And it's going to say, okay, I need to return 5 times the factorial of 4.
Right.
So now it needs to calculate the factorial of
Yeah,
4.
so it calls itself again.
Exactly.
With n equal to 4 this time.
Exactly. And it goes through the same process, right?
Yeah.
Is 4 equal to 0 or 1?
No.
So it returns 4 times factorial of 3.
Right.
And it keeps doing this, right? 3 factorial becomes 3 times 2 factorial. 2 factorial becomes 2 times 1 factorial.
Yeah.
And then finally we get to 1 factorial.
Yeah.
And that's our base case.
Right, because 1 is equal to 1.
Exactly.
So it returns 1.
Exactly. And so now we can work our way back up.
Yeah.
So 1 factorial is 1, 2 factorial is 2 times 1, which is 2, 3 factorial is 3 times 2, which is 6, and so on.
So it's like each recursive call is waiting for the one below it to finish and give it a result.
Exactly.
And then it can use that result to calculate its own result.
Exactly. And eventually gets all the way back up to the initial call of factorial of 5. And it has all the values it needs to calculate the final answer.
Wow, that's pretty cool.
Yeah, it's a little bit mind-bending.
It is.
But once you kind of like see how it works, it's pretty elegant.
Yeah, it is.
So let's look at one more example. Let's look at the Fibonacci sequence.
Okay.
So remember, the Fibonacci sequence is that sequence where each number is the sum of the 2 preceding numbers.
Right, so it starts with 0 and 1, and then the next number is 1 because 0 plus 1 is 1, and then the next number is 2 because 1 plus 1 is 2, and so on.
Exactly. So it goes 0, 1, 1, 2, 3, 5, 8, 13, and so on.
Yeah.
And we can also define a recursive function to calculate the Fibonacci sequence.
Okay, how would we do that?
So we would start with def Fibonacci, open parenthesis, and close parenthesis, colon.
Okay.
And again, the first thing we're going to do is check for the base case.
Okay, so what's the base case for the Fibonacci sequence?
So the base case is that if n is less than or equal to 1, then we just return n.
Okay.
So if n is 0, we return 0. If n is 1, we return 1.
Right, because those are the first two numbers in the sequence.
Exactly. And then if n is greater than 1, then we do the recursive step.
Okay.
So we would say, else return Fibonacci of n minus 1 plus Fibonacci of n minus 2.
Wow, so this time it's calling itself twice.
Exactly.
Once for n minus 1 and once for n minus 2.
Exactly. And that's because to get the nth Fibonacci number, you need to add together the n1th Fibonacci number and the n2th Fibonacci number.
That's really clever.
Yeah, it's pretty neat. And so if you call Fibonacci of 5, it's going to call itself to calculate Fibonacci of 4 and Fibonacci of 3.
Yeah.
And then to calculate Fibonacci of 4, it's going to call itself to calculate Fibonacci of 3 and Fibonacci of 2.
Right.
And it keeps doing this until it gets down to the base cases.
And then it works its way back up, adding the results together as it goes.
Exactly. And the source that we're looking at actually has a loop that prints the first 10 Fibonacci numbers.
Okay.
And it just does that by calling Fibonacci of n for n from 0 to 9.
So it calls Fibonacci of 0, then Fibonacci of 1, then Fibonacci of 2, and so
Yeah,
on?
exactly. And the output is 0, 1, 1, 2, 3, 5, 8, 13, 21, 34.
Cool.
So that's how you can use recursion to calculate the Fibonacci sequence.
That's really neat.
But we have to be careful with recursion,
Well,
right?
absolutely, yeah.
Like we said, the most important thing is that you always have to have a base case.
Yeah, if you don't have a base case, your function will just keep calling itself forever, and you'll get an infinite loop.
And then your program will crash.
Exactly. And it's not just about having a base case, it's about making sure that each recursive call is actually getting you closer to that base case.
Right. You have to make sure that you're making progress towards that stopping condition.
Yeah, otherwise you're just going in circles.
Exactly. And the other thing to keep in mind with recursion is that it can be less efficient than using a loop.
Yeah, that's true. Sometimes a loop is just a more straightforward and efficient way to solve a problem.
Exactly. Especially for problems where you're doing a lot of repeated calculations, recursion can be really slow.
Yeah, because
Right.
each recursive call has some overhead associated with it.
Exactly.
Yeah,
So you have to kind of like weigh the pros and cons.
right.
Recursion can be really elegant and it can make your code really concise.
Yeah.
But if performance is a big concern, then you might want to consider using a loop instead.
Right. It's all about choosing the right tool for the job.
Exactly.
Yeah.
So, okay, I think we've covered a lot of ground today.
Yeah, we have.
Let's just do a quick recap.
Okay.
So functions, they allow us to create reusable blocks of code, which is super helpful for making our programs shorter, easier to maintain, easier to read, and easier to debug.
Absolutely.
And they help us break down complex programs into smaller, more manageable pieces.
Right.
And then recursion. It's a way of solving problems by breaking them down into smaller, self-similar subproblems. And it's really useful for certain types of problems.
Mm.
But we have to be careful to always have a base case and to consider whether a loop might be more efficient.
Right. Always think about the base case and the efficiency.
Exactly.
Yeah.
So I think that's a good place to stop for today.
Yeah, I think so too.
But before we go, I want to leave you with a thought.
Okay.
Think about your own life,
Okay.
your work, your hobbies, whatever.
Yeah.
Are there any tasks that you do that could be broken down into smaller, repeatable steps?
Right.
Like maybe you have a process that you go through every morning to get ready for work.
Yeah.
Or maybe you have a hobby that involves a series of steps.
Right.
Well, if you think about it, you can actually apply the principles of functions to those tasks.
Yeah, you can break them down into smaller chunks and then focus on one chunk at a time.
Exactly. And that can make the whole process feel less overwhelming.
Yeah, and maybe even more efficient.
Exactly. And what about recursion? Can you think of any problems that you face that could be solved by tackling a smaller version of the same problem?
Like breaking it down into a sub-problem that's similar to the original problem?
Exactly.
That's an interesting question. I'll think about that.
Yeah, it's something to chew on.
Definitely.
Because, these programming concepts, they're not just limited to coding.
Right.
They can actually help you to think about problems in a more structured and efficient way in all areas of your life.
Yeah, that's a good point. It's all about problem solving, really.
Exactly. So thanks for joining us for this deep dive. I hope you learned something new. And if you did, please share it with your friends.
Yeah, spread the knowledge.
And until next time, happy coding.
Happy coding.